Yeah.
What's up, mathletes? It's Math Life here, and today we're talking about rate of change. We're going to find rate of change in 3 different ways. All right, so from some words here where we don't have to do too much work, we're just kind of pointing it out. We're going to have to do some where we just have 2 values and just do some dividing. And then the last type is using a table to find some changes in y over change in x to help us find this rate of change. So let's look at the first example here. Mr. Hoffman traveled a rate of 64 miles per hour on the highway on his way to work. Hopefully he wasn't speeding. I don't know what highway he was on. So rate of change is how fast was he going per something, per one. It's kind of like the unit rate. So in this case, the answer is right there. The rate of change is 64 miles per hour. So again, 64 miles per hour. The problem is right. The answer is right there. In the second problem, represents the number of hours. X represents the number of hours, and Y represents the total money. In this case, we have our equation. This is like our standard form of the equation, and the rate of change is right in front of the X. So in this case, it's 50.50 or 15 and 5 tenths. Sorry, I don't want to mess up my words there. All right, so again, problems where they're just right there. You don't have to do any math, you just have to pick them out from the problem. The second type of rate of change is when we're looking at an example and there are 2 different points. So, Joey Chestnut, I don't know if you know who he is. He's a professional eater. He eats hot dogs on the 4th of July. You might want to check it out on YouTube and check out the contest. It's kind of disgusting, but interesting. So, Joey ate a record 69 hot dogs in 10 minutes at the Nathan's Famous Hot Dog Contest in 2013. What was his rate of change? Well, notice it's not really there. There's nothing there. It's telling us, say, per minute. So we actually have to do some math. So I'm looking for the hot dogs per minute. So how much does he eat per minute? And once we figure this out, it's kind of disgusting. So we know that he ate a total of 69 hot dogs in 10 minutes. How much did he eat in 1 minute? Well, we take these 2 numbers, we divide them. So 69 divided by 10 will give us 6.9 hot dogs per minute. Okay, so again, we're looking for the hot dogs per minute. That will give us our rate of change. The second type of example here, we have the temperature at noon was 88 degrees Fahrenheit. By 4 p.m., the temperature was 72 degrees Fahrenheit. Find the rate of change. So this time we actually have 2 sets of data points. We have a noon at 88, and we have a 4 p.m. at 72. So when we have 2 sets of data points, we're going to make a table. And we're looking for the rate of change. So we're looking for the degrees per hour. And again, we're looking because noon to 4 are kind of per hour in this case. We'll make a table. And this is where it gets a little confusing. What goes first? What goes second in our table? We'll think about this. What changes the other one or causes the other one to change? Well, the number of hours causes the temperature to change. So hours is here, and temperature is here. So we started at noon, and we went to 4, and we started at 88 degrees, and we went to 72 degrees. So let's look at our change. From 12 to 4, that's 4 hours. And from 88 to 72, well, we look, we're actually going down. How are we going down? Well, we subtract 72 minus 88, and we're actually going down 16 degrees. Now, we put this information into our fraction because we went degrees per hour. So negative 16 degrees Fahrenheit divided by 4 hours. But we want it per 1 hour, so we divide those two numbers. That's going to give us negative 4 degrees Fahrenheit per hour. And that would be our rate of change. So glad you can see that. All right, and the last problem. Sometimes it's already set up in a table, so we just have to figure out the rate of change from there. One of the most popular TV shows in recent years has been The Biggest Loser. Guess what? There's a new season this year. Check it out. The table below shows the weight of an individual at the show at 2 different time periods. Again, we have 2 sets of data. So that's how we kind of know we're going to make a table. Find the rate of change. Well, we want to know the difference, so we're going to figure out the pounds per day. And if you're unsure, think about the other way, like day per pounds. That kind of doesn't make sense in our brain, so pounds per day is what we're looking for. So in this case, days, we know we're going up how many days? 12 days. Right, 5 plus 12 is 17, or 17 minus 5 is 12. And what are we going down here? 276 minus 306. And notice we're decreasing, so that's 30 pounds. We're looking for pounds per day, so negative 30 pounds over 12 days. And use your calculator here. So divide those. Hopefully, I think I did this right. I think it's negative 2.4. No, negative 2.5 pounds per day. Negative 2.5 pounds per day. Double check me, fact check me on that. I think I'm right, but if your calculator says something different, I think I'm good. All right, so there are 3 ways to do this problems. These problems, there's one where the numbers are right in the equation or the problem for you. The second way is where you have 1 set of data points and you need to divide those 2. And the third way is when you have 2 sets of data points, set up the table, and then divide to figure out your rate of change. All right, hopefully you enjoyed this video. Don't forget to hit that like button. Smash it if you can with your calculator. Don't break your screen though. Don't forget to hit that little bell for notifications. Math you later. Peace.